Okay, now it asks us to calculate the magnitude of the tension, and you can see that your free body diagram here has been useful. Okay, and this is the gravity, force of gravity. Now, we need to find out what the electrical force is. So it's going to be K Q1 Q2 over R squared. That is going to be 9 times 10 to the power 9 times 9 times, sorry, not 9, 0.9, 0.9 times 10 to the minus 6 times 0.5 times 10 to the minus 6 over distance apart. 20 centimeters must convert, and you get a mark for this, 0.2 all squared. You see that was 20 centimeters, which converts into 0.2 meters. And for that, you will get a mark, so don't make that mistake. You'll also get the answer correct. Now, that force must be equal to, all right, now here's an interesting point. You see what's happening here? Now, this is the physics of the thing. This body is in equilibrium. Now, that means that the vertical forces are in equilibrium. So there's the weight, and here upwards is going to be a component of the tension. And in fact, that component is going to be T sine, let's see, that component there, that vertical is going to be, all right, here is 83, this is 7, this is 83, so it is going to be, this vertical component is going to be T times the cosine of 83 degrees, I think. That is correct. Yes. T times the cosine of 83 degrees. And if I knew what the weight was, I could say, well, all right, these two things are equal because this point is in equilibrium along the vertical axis. But you see, I don't know what this is, but just because you don't know it doesn't mean that you're high and dry. Because what I do know is I know an angle, 7 degrees, and I know that this body is in equilibrium also in the horizontal. So this tension has a component in this direction. Now I can work out what Fe is over here. That I've got. And it must be equal to the, you see here, this is 7 degrees. So this is going to be T sine 7 degrees. And I know that that force must be equal and opposite to the electrical force. So this is going to be T times sine 7 degrees. So if I work all of this out, I get T is equal to all of this over here divided by the sine of 7. And if I work this out, I find that the tension is equal to 0.83 of a Newton. Okay? 0.83, you could, if you said 0.82, you would also be correct for getting that. But this one here is just a matter of calculating all of these things, dividing that answer by the sine of 7, and I just want to make sure that you see where the sine of 7 comes from. It's because we are not opposing the electrical force with the entire tension, because the tension is out in this direction. We oppose the electrical force only with the tension in the horizontal direction. And so that, you'll see there, is going to be sine of 7, so it's T sine 7, and hence you can work out the tension.